Hello, this is our last section of chapter 8. Just so y'all know, this is like my fourth time recording this video. The first time I did it, you couldn't hear me. Second time I did it, I messed up. Third time I did it, I don't even know what happened, so this is my fourth. Okay. 8.4, surface area and volume of similar solids. So let's talk about similar solids. They are solids that have the same shape and proportional corresponding dimensions. I'm going to get rid of my face. Bye. So that means that if you have two cylinders, they're obviously the same shape because they're both cylinders, but say one of them is a little bigger than the other, they could, if they are proportional, if their sizes are proportional, then that's a similar solid. Okay, let's get started. Actually, maybe we should talk about what surface area is. Let me go back to my face. So surface area is if you took this shape, this any three-dimensional object, and you just measured the area of all of the faces, all of the sides. Or you can kind of look at it like if you took the net of it, which is basically this for this shape. It's like a flattened version of the three-dimensional shape, and you just measured the area. That's surface area. Okay? So we're going to talk about surface area and volume. First, which cylinder is similar to cylinder A? So we have cylinder A over here, and we need to figure out if B or C are similar to it. We are going to do this by setting up ratios. If you set up a ratio for cylinder A, you can take any dimension, so let's take the height, and put it over the radius. The height of the cylinder is 4 and the radius is 6. If we were to simplify that, we would get 2 over 3. So the proportion, or the ratio for cylinder A for height over radius is 2 to 3. If we look at B, and we used the same formula, h over r, height over radius, and if the numbers are equal, then that means they're proportional. If they're not proportional. So if we look at the height is 3, the radius is 5, and we can't simplify it, and 3/5 is not the same as 2/3, so cylinder B is not proportional or not similar to cylinder A. Let's do the same thing with cylinder C. Let's take h over r, height over radius. The height is 5, the radius is 7.5, and we need to simplify it. When we have a decimal in a fraction, we can get rid of the decimal just by moving it to the right. Whatever we do on the bottom, we have to do to the top. Move it over. So then we become 50 over 75. And let's simplify it. Once we simplify it, I'll just do that out. Divide both by 5, you get 10 over 15. Oh, I can divide by 5 again. 10 divided by 5 is 2. 15 divided by 5 is 3. And oh my goodness, they match. So since the ratios match, that means they're proportional to each other, which means that cylinder A and cylinder C are similar. So the answer is cylinder C. Next. In example 2, it shows that the cones are similar. So it tells you they're similar already, and we just need to find the slant height. The slant height is the diagonal or the hypotenuse of this center triangle. So it's just the center. It's the slant height, not the actual height of it. Okay. But since it says they're similar, we can set up a proportion. The proportion I set up is going to be cone x on one side, and I'm going to set it equal to a ratio that has cone y on the other side. So if we set up the ratio, we can do either the slant height over the radius or the radius over the slant height. It doesn't really matter. So I'm going to do slant height, which is 13, over the radius, which is 5. And I'm going to look at cone y and do the same thing. Since slant height was on the top in cone x, slant height needs to be on the top in cone y. So that is a cursive L, this symbol is a cursive L, and slant height is always denoted with the variable L. Since radius was on the bottom in cone X, radius has to be on the bottom in cone Y, so that's 7, and I can just do the butterfly method to solve for the slant height. 13 times 7 equals 5 times L. 91 equals 5L. Divide by 5 on both sides, and you will get that slant height is exactly, I believe it's 18.2. Yes, 18 2/10 yards. Don't forget your units. Okay, next. When dealing with surface area of similar solids, you can set up this wonderful proportion right here, which is kind of cool. It's a way to figure out what a surface area is if it's missing. So if you take the surface area of one, put it over the surface area of the other, and set that equal to little a and little b. So little a and little b are not the same as the big A and the big B. The big A and the big B are talking about the actual solids, the whole thing. Little a and little b are talking about dimensions on that solid. So the surface area, the ratio of the surface area is equal to the dimensions squared. Let's try it. So it tells you that the pyramids are similar, and it asks us to find the surface area for pyramid A. So by using that formula that we had earlier, we can set the surface area of A on top, which is actually missing in this problem, so we can use a variable. And the surface area on the bottom is the surface area of B, which is 600. And we can set that equal to the dimensions. So in the example that I just showed you, the definition, it was talking about a radius. But in this problem, there's no radius because there's no circle. This is a square pyramid. So it's just talking about any dimension that's given. You just have to use the same one. So if pyramid A is showing us the height, then we have to use the height in pyramid B. So little a is going to be 6. It's the height of pyramid A. And little b is going to be the height of pyramid B, which is 10. And we can solve it. So x over 600 equals 6/10 squared is 36 hundredths. Then we can use the butterfly method to solve for x. 36 times 600 is, I believe it's 221,600. Divide by 100. These cancel, and x equals 216. So we just found the surface area for pyramid A. It's 216 feet squared. Surface area is always in square units. Okay. You try these two. And here are my answers. Notice in the second one, I used the diameter. You don't need to change it to a radius because you just need a dimension. Doesn't matter what the dimension is, but those are my answers. Don't forget your square units. Okay, next, volume. So volume of similar solids goes the same way for surface area, only instead of squared, it's cubed. Let's get started. So I'm going to do 5, you're going to do 6. Round to the nearest 10th. Oh, actually I did them already. So if you want, you can pause the video now, try it on your own, but it's the same thing. So I'll do number 5 with you, I'll talk it out. So you have to find the volume of the red solid. So I put x there, and then I put it over 288, because that's the volume of the blue one, equals, and then let's look at the dimensions. The dimensions in the red one are 5 and 12 in the blue one. Now, the only difference is from surface area is that you cube it. So 5 cubed is 125, and 12 cubed is a large number, so make sure you use a calculator to not waste time. And then you do the butterfly method, divide, and you get 20.8. I forgot to put the units, but they are centimeters. Okay. Second one, you want to find the volume of the red square pyramid. So You can set up this proportion and solve it the same way. I forgot my units. They should be inches cubed. 21 3/10 inches cubed. Okay, go on Big Ideas Math and try it yourself.